All right, this is the key on solving radical equations. And so these problems here should help you with the worksheet that you have to do. So the problems are similar. Now in solving a radical equation, and so a radical equation is an equation that contains a radical. So for example, you could have square root, so this is a symbol for square root. You could have cube root. So you see this number 3 right here where I have it located. So here's your radical notation. So this number here is called the index. So that's called the index. So this index here is 3. If there's no number here, that index is understood to be a 2. So hence the word square root. Okay. So this is cube root. And then this would be fourth root. Fourth root. And so on. So this number right here, those numbers are represent the index. So there's no number there. That's understood to be a 2. So square root, cube root, fourth root. So radical equation is an equation that has a radical symbol. Notice that this radical symbol is a square root. That number here that you don't see is understood to be a 2. So in solving a radical equation, the idea, first of all, and there are different types of radical equations, but the one we're going to look at in this lesson is where you're going to isolate that radical by itself. So you want to get this right here by itself. So if you cover it up, then what you want to do is get rid of this 2. So right now I'm adding 2. The opposite would be to subtract 2, just like you would with the linear equation. And so when I combine like terms now, this is 0. So I get the square root of 6x minus 1 is equal to, and then 5 minus 2 is 3. Okay, now, one of the other things you have to remember about a radical equation is this. So for example, suppose I had that the square root of x is equal to, let's say, 4, right? And so you can look at this right here and solve for the variable x. So the square root of what number is 4, right? So intuitively, you can see that x has to be 16 because the square root of 16 is equal to 4. Okay, but mathematically, what do we have to do here to get that value of x? Because this right here is not as simple as this one. You can guess at this and say that x is 16 because you know stuff about a perfect square. But here, it's not that simple. So the idea is this. So if you go back to that square root of x equal 4, so to get x by itself, right now I'm taking the square root of it, right? So the opposite of taking the square root is to square. So the opposite of square rooting is squaring. But what I do to one side, I have to do to the other, just like you've been doing since day 1 of this course. If you have an equation, what you do to one side, you do to the other. So notice I'm squaring both sides because my index is 2. I'm taking the square root of x. The opposite of square rooting is to square. So I square both sides. And so what happens is that the square root and the square undo each other, so you get x equal, and then 4 squared. Remember, 4 squared means 4 times 4, which is 16. And that's what you guessed here. So that's the idea you want to use here. So when I do that, I have that square root by itself. So let me go ahead and rewrite this over. So now what I'm going to do is to get rid of that square root, because I want to get x now by itself, but that square root is in the way, right? So the opposite of square rooting is to square. So I'm going to square both sides, just like this. Notice I put both of those sides in parentheses. And then now we're almost done. So now the square and the square root undo each other. So I'm left with 6x minus 1 equal, and then 3 squared, remember, means 3 times 3, which is 9. So notice I went from a radical equation to a linear equation. All right, so now to solve this linear equation, I'm going to have to get x by itself, so I'm going to add 1 to both sides. So I get 6x, combine like terms at 0, equal 10, and then divide both sides by 6. Remember, I have 6x equal 10. So to get x by itself, right now I'm multiplying by 6. The opposite is to divide by 6. And so when I reduce, I get x to b. And make sure you reduce this. So both of those are divisible by 2. So that's 5/3. Okay, now something else you got to remember. Whenever, whenever you raise both sides, both sides of an equation to an even power, okay, to an even power, which I did. I raised both sides to the second power. 2 is an even number. To an even power, you must check for extraneous solutions. So extraneous means the idea of false. So those are false solutions. So basically what that means is this. So obviously a square root equation is not the same as a linear equation, right? Okay, but notice this x equal 5/3 is a solution to this linear. But the question is 5/3 a solution to the original? So you must check into the original equation. Okay, so that's one of the things that some students forget to do when they solve a square root equation, is they forget to check the solution at the end. They forget about the idea of those extraneous roots, the extraneous solutions. So all you do is go back to the original, and where we see the variable x, you substitute 5/3. So let's go ahead and check this. So let's check to see if x equals 5/3. So always go back to the original. So we have the square root of 6x minus 1 plus 2, and I want to see if that's going to equal 5 when x equal 5/3. All right, so here we go. So notice I only see x once, so that's going to make it a little bit easier. So I have the square root of 6 times x is 5/3, just like this, minus 1. Okay, so wherever I saw the variable x, I substitute 5/3. So notice this is this. Whatever that is, I'm going to add 2, and then I want to see if that's going to equal 5. Okay, so let's think about this. 6, let me go ahead and use this. 6, right here, see this right here? 6 times 5/3. The 3 goes in 3 one time, 3 goes in 6 2 times, 2 times 5 is 10. So that's 10, right? So I get the square root of 10 minus 1. See, that's 10, right? Minus 1. 10 minus 1 is 9. So I get the square root of 9, which we know is 3. So this is 3 right here, right? So I get 3 plus 2, and indeed, that does equal 5. All right, so x equals 5/3 is a solution. It is not extraneous, so we're good. So 5/3 is okay. So just remember, though, whenever you raise both sides to even power, you must check for extraneous solutions. Okay? All right, and that's all, and that's how you check. You just go back to the original. Always go back to the original, and where we see the variable x, you substitute what you just found as the solution. Okay, so let's look at number 2. So here's number 2. So number 2, I have, I'm going to get a sheet of paper. All right, here's number 2. All right, I have the square root of 3x plus 18 is equal to x. All right, so remember, notice this time I have x on both sides, don't I? In the previous problem, the variable x was just on one side. It was here. It wasn't here. So this made it a little bit easier than this one does. But the idea is once you isolate that radical, in this case the square root, once you isolate the square root, then you square both sides. That's your steps. First, get the square root by itself, and then you raise both sides to the second power. So that's what you have to do here. So notice the square is already by itself, right? Hey, so there's nothing else we had to do here. The square root is already by itself. So then what you're going to do, all right, let me go ahead and show you. So I just wrote this over. Then what you're going to do is to get rid of that square root, you're going to square both sides. Just like that. And so now notice the square and the square root undo each other. So you're left with 3x plus 18 is equal to, and remember, x times x is x squared. Okay, so that's where I'm at. So notice I no longer have that square root. Just like over here, I no longer had that square root. So I went from a square root equation to a linear equation. Here, notice I went from a square root equation to a quadratic equation. That's quadratic. Okay? And so let's go ahead and solve this quadratic equation. So one of the things you got to remember about solving a quadratic equation is you have to put this in standard form, meaning you want 0 on one of the sides. Well, since x squared has a positive coefficient on this side, let's bring everything to this other side. So remember what you do. You got to subtract 3x on both sides, right? And then you also have to, well, let me go ahead and do it. Let me do it in steps. So that's 0. So I get 18 equals x squared minus 3x, right? Then we're going to subtract 18 from both sides. Remember, what you do to one side, you do to the other. So I get 0 equals x squared minus 3x minus 18. Okay? All right, so I'm going to go ahead and transpose both sides. So 0 equals this right-hand side means the same thing as saying the right-hand side equals the left. Okay, so now I've got to solve this quadratic equation. It's now in standard form. The one that we're going to have are going to be factorable. So that's going to be the easy kind for us. They're factorable. So if you don't remember how to factor very well, notice this is an equation, right? A quadratic equation. You could use the quadratic formula if you want to. You could use quadratic formula, and we'll do it both ways. So the factoring, if you're good at factoring, and this is the easy kind because the coefficient of x squared is 1, then let's just go ahead and do that first. Let me go ahead and put use quadratic formula, or in this case it is factorable. Okay, so x times x is x squared. So I want, remember last times last. So I want two numbers whose product is a negative 18, and when I add the outer and the inner, I get a negative 3x. So that's what that says. And so it looks like the one that's going to work will be a 6 and a 3. 6 times 3 is 18, but I want a negative, right? And I want that middle sign to be negative. So it looks like the 6 has to be negative, and the 3 has to be positive. And you can always check your work before you go into the next. So when I check this right here, x minus 6 times x plus 3 using FOIL, first times first, so x times x is x squared. The outer is 3x. The inner, a negative 6 times x is a negative 6x. And the last, a negative 6 times 3 is a negative 18. Combining like terms, I get x squared. 3x and a negative 6x is a negative 3x minus 18. And this is what we had here. Okay, so I factored it correctly. Now remember, once you factor, the next step is to use a zero factor property. So meaning that when you have two or more factors whose product is 0, then one of these has to be 0. So we got to say x minus 6 equals 0 or x plus 3 equals 0. So notice I went from a square root equation to a quadratic equation to two linear equations. And all I do is solve for x here. So x equals 6, x equal negative 3. Okay? Now, before we go any further, let's do the one with quadratic formula. So let's do the same problem using the quadratic formula. So remember, the quadratic formula says this: x equals the opposite of b plus or minus the square root of b squared minus 4ac. All of that is being divided by 2a. And so in this case, remember a, b, and c. So a is a coefficient of x squared. So a is 1. B is a coefficient of x. So b is negative 3. And c is the constant, which is a negative 18. Okay? And so now I get x equal the opposite of b. Well, b is a negative 3. The opposite of a negative 3 is a positive 3. Plus or minus the square root of b. Always put that in parentheses. It is a negative 3. I've got to square it. That's what this says. I square whatever b is. Minus 4 times a. A is 1 times c, which is a negative 18. All of that is being divided by 2 times a, which is 2 times 1. Okay, now simplifying this, I get 3 plus or minus the square root of negative 3 times itself is 9. A negative 4 times 1 times a negative 18. So a negative times a negative is a positive, so I'll be adding something. And so use your calculator. You're going to say 4 times 18, which is 72, all divided by 2. Now 72 plus 9 is 81, right? So I get the square root of 81 divided by 2. So 3 plus or minus the square root of 81 divided by 2. You have to remember the square root of 81, 81 is a perfect square, so the square root of 81 is 9. So just to show you, so remember the square root button is, you can't see it very well, but it's right here. See right here? So I got to go second to get to it. So second, let's do it again. So second square root, okay, so the square root shows up, 81 equal, you see you get 9, because 9 times 9 is 81. So this becomes 3 plus or minus 9 divided by 2, and then I'm going to split it apart. And so I get 3 plus 9 divided by 2, and then 3 minus 9 divided by 2. Well, 3 plus 9 is 12, right? 12 divided by 2 is 6, which is what this is. 3 minus 9 is a negative 6 divided by 2. So negative 6 divided by 2 is a negative 3, which is what this is. Okay, so you could have done this by factoring, found the solutions by factoring, or used the quadratic formula. Now, remember, whenever you raise both sides, that should be both sides of an equation to an even power, you must check for extraneous solutions. So notice at some point I raised both sides to even power, right? So that means I have to check both of those solutions into the original equation. So let's check x equals 6. So we're going to check for extraneous solutions. We're going to check x equals 6. So you go back to the original, which is this right here. The square root of 3x plus 18 and is equal to x. So wherever we see the variable x, I'm going to substitute 6. So I get the square root of 3 times 6 plus 18, and I want to see if that's going to equal 6. Well, 3 times 6 is 18, right? 18 plus 18 is 36. So the question is the square root of 36 equal to 6? And the answer is yes, because the square root of 36 is 6, and 6 equals 6. Then I go here, and I check x equal negative 3. So when I check x equal negative 3, go back to the original. I get 3x plus 18 equal x. So where I see the variable x, I substitute negative 3. So I get the square root of 3 times negative 3 plus 18, and I want to see if that's going to equal negative 3. Well, 3 times negative 3 is a negative 9. So I get the square root of a negative 9 plus 18. Negative 9 plus 18 is 9. So I get the square root of 9, and the square root of 9 is 3. But 3 does not equal negative 3. So that means that this right here is extraneous. That's a false solution. So x equal negative 3 is a solution to this quadratic equation, but it's not a solution to the original. So the only solution then is x equal 6. All right? So make sure you understand that when you do some of these, it is possible you may end up with something being extraneous. So extraneous solution means that that's not a solution. So the only solution is x equals 6. And make sure when you're doing this assignment, you're looking at what the work should look like. This is what the work should look like. So you must show that you're checking. Okay? You have to show that you're checking. So make sure you check this. All right, so let's look at one more. This is going to be number 3. All right, here's number 3. We have the square root of 9x plus 22 equal x plus 4. All right, so the radical is already by itself. All right, so remember when the radical is already by itself, but notice I do have variables on both sides. So the radical is already by itself. And so I'm going to square both sides. So right now I have a square root. To get rid of that square root, I'm going to square both sides. And so the square and the square root undo each other. So I get 9x plus 22 equal All right, now we got to figure out what this part is. So remember, x plus 4 squared means x plus 4 times itself. So in a FOIL, when you multiply two binomials, we can use the FOIL method. I get x times x is x squared. The outer is 4x. The inner is also 4x. And the last, 4 times 4 is 16. Combining like terms, I get x squared. 4x plus 4x is 8x plus 16. So that goes here. So this is this. So remember, when you square a binomial, you get three terms. So x squared plus 8x plus 16. So notice I went from a quadratic equation, I went from a radical equation, a square root equation, to a quadratic equation. So now we're going to put this in standard form, just like we did number 2. So remember number 2, we went from here to here. So I'm going to go ahead and subtract 9x from both sides. When I do that, this is 0. I get 22 equal x squared. 8x and a negative 9x is a negative x plus 16. Subtracting 22 from both sides. Combine like terms. 22 minus 22 is 0 equal x squared minus x. 16 and a negative 22 is a negative 6. And I'm just going ahead and transpose both sides. So x squared minus x minus 6 equals 0. Now remember, the ones we're going to deal with are factorable, so let's just go ahead and factor this. And so when I factor this, I get x, because x times x is x squared. For 6, let's try 3 and 2. So let's put 3 here, 2 here. The last sign's negative, so that means these signs are different. And I want the outer and the larger to add up to be a negative x. The only way that can happen is if 3 is negative and 2 is positive. And if you check it, just real quick, if you were to check this right here, I get x minus 3 times x plus 2. When I FOIL it out, x times x is x squared. The outer, x times 2 is 2x. The inner, negative 3 times x is a negative 3x. And the last, negative 3 times 2 is a negative 6. Combining like terms, I get x squared. 2x and a negative 3x is a negative x minus 6, which is what this is. So I factored this correctly. So now I'm going to set, remember, I have two factors whose product is 0. So that means one of these has to be 0. So x minus 3 equals 0. X plus 2 equals 0. So notice I went from a square root equation to a quadratic equation to two linear equations. And so now to solve these linear equations, those are easy. X equals 3, x equals negative 2. But remember, you have to check for extraneous solutions. Alright, so check for extraneous solutions, because remember, when you raise both sides of an equation to even power, you could introduce false solutions. So these two numbers are solutions to this quadratic, but they may not be solutions to the original. So let's check x equals 3. Alright, so I always go back to the original, and remember, this is the original. So my original is the square root of 9x plus 22 equal x plus 4. So I already see the variable x, and I see it on both sides. I'm going to substitute 3. So I get the square root of 9 times 3 plus 22, and I want to see if that's going to equal 3 plus 4. Well, 3 plus 4 is 7, right? So let's see what this side is. 9 times 3 is 27. So I got 27 plus 22. 27 plus 22 is 49. So that's the square root of 49, which is 7. So that works. So x equals 3 is a solution. Let's check x equals negative 2. Alright, so go back to the original, which is this right here. So I'm just going to go ahead and rewrite it over. And wherever you see the variable x, you're going to substitute negative 2. So I get the square root of 9 times negative 2 plus 22. And I want to see if that's going to equal negative 2 plus 4. Well, 9 times negative 2 is a negative 18. So I get negative 18 plus 22. Negative 18 plus 22 is 4. So it's the square root of 4. And the square root of 4 is 2. Over here, negative 2 plus 4 is also 2. So those work as well. So both of those are going to be solutions. So your solutions are x equals 3 and x equals negative 2. Over here, remember, there was only one solution. One of these did not work, right? So this one was extraneous. So here you don't have any extraneous solutions. Both of those are solutions to the original equation. We just verified that right here. All right, so that is how you're going to solve, in this case, how you're going to solve radical equations, in this case, square root equations. All right, so that should help you with some of the problems you're going to see on the assignment.